Oh, students looking at the math connections in 2.2. I think I signed, what did I sign? 2.2. I did number 2, 4 through 7, 17 to 18. Let's take a look. So 2, which of the following sets are not well defined? Okay. So again, not well defined. Be looking for, are there terms that are subjective where you might have a different idea of what that means than someone else? What we want is we want terms that are objective. It means no matter who you are, you're going to see it the same way. So for example, this set of natural numbers greater than 100, everybody's going to write down the same group for that because it's very clearly defined. Whereas the set of great books, what makes a book great, right? So you and I might have a different group for that, which means it's not well defined. Okay. Let's see, I think we had a question on E. So notice the set X, as long as X does not equal itself, and X is a natural number. So pick any natural number and put it in. So is it true? Does 3 not equal 3? No, 3 actually does equal 3. That should happen. So what number is not equal to itself? And hopefully you come up pretty quickly with there aren't any. Well, if there aren't any, that would mean there would be no elements in this set. So the set that you come up with there are no elements, and the set I come up with, which is there are no elements, are exactly the same. Everyone reading that would come up with the same set. So yes, it is well defined. It just happens to be the empty set. Okay. Oh, let's see your question 4. Explain why the set containing the empty set has empty set as an element and also as a subset. These questions really ask you to get into the terminology. What does it mean to be an element? What does it mean to be a subset? Okay. Oh, for us, what we've talked about already is, at least I hope you remember, is the empty set is a subset of every set because you can never prove that it isn't. Okay. So if you want to prove a counterexample, you would have to show, oh, the empty set has to be a subset of some set. I think that's false. All right, well, tell me why. Because I can think of an element that's in the empty set and it's not in here. And I would say, perfect, you can think of an element that's in the empty set. Can you tell me what that element is? The element that you're thinking of that is in the empty set. Because when I write the empty set out, there's nothing in it, which means you'll never get the true false that you need to make this statement false. As a matter of fact, there is nothing in the empty set. So you always fail the condition, which means the statement is always true. So that's why it's always a subset. Why is it an element? Well, if you want to, go back to the paper bag analogy from the prior video. So if you have like the empty set and you think of it as like a paper bag, and then you take that paper bag and you put it into another paper bag, is the outer paper bag empty? No. What's inside of it? An empty paper bag is inside of it. So that's why the empty set would be an element of the set that has only the empty set inside of it. Be an element, and it would be a subset for the first reason. Okay, we talked about this one in class. How do you show something's not a subset? Don't forget, it's a conditional statement. So you need to find something that's in A and is not in B. That's what you're looking for. Okay, 6 is a difference between a subset and a proper subset. So we've defined those. Try to make sure you go back. What is the definition of each? What is the difference between them? And I'm asking you to put that difference into words. And then these symbols, hopefully you've got those down now. One is element, one is subset. Give examples, it says. Not too big of a deal there. Hopefully you feel comfortable with those. Let's jump over here. So 4 to 7, 17 to 18. I think we get into connecting math to the classroom. Ah, yes. The CMCs used to be called QFCs, so questions from the classroom. Now they're connections to the classroom, which is fine. Student asks, if A is a subset of B and B is a subset of C, do we know that A is a subset of C? Well, you got to go to the definition. What does it mean to be a subset? If A is a subset of B, every element of A is in B, guaranteed. And now B is a subset of C, so every element of B has to be in C. But don't forget, every element of A was in B, which means every element of A is in B, and all of those are in C. So yeah, by definition, every element of A has to be in C. And you could kind of show it by saying, yes, everything is in here. If you wanted to, you could also show it as a Venn diagram if you prefer a picture form. Okay, so what would that look like, right? If you're going to do picture form, give yourself a little space and then, oops, almost lost everything there. Here we go. So give yourself a little space and say, okay, so here's A, whatever A is, right? Everything in A is completely contained in another set called B, right? And we know everything in B is completely contained in another set called C. So what you can visualize then is that anything you can think of in A has to be in B, which has to be in C. So everything in A has to be in C. And visually, you can justify it that way as well. So depending on the level of student that you're working with, you could use a visual explanation, or you could use more of the definitions. Okay, a student says two sets A and B, either A is a subset of B or B is a subset of A. Maybe. So I might think this student is probably thinking of maybe like equality. Like we know that with these symbols, right? If you pick any two numbers, one of these symbols has to be true. Okay, one of them. So either 2 is less than or equal to 3, or 3 is less than or equal to 2. I mean, it has to be one of those, right? So with those symbols, then exactly one would be true. So it's tempting to think that because that symbol does it, then the subset relationship has to be true for any sets. A is a subset of B, or B is a subset of A. But just use the definition. What is the definition of a subset? If a student is asking you something, go to what the words mean. If it's a subset, every element of A has to be in B. Okay, what if that's not true? Think of an example where that's not the case. Find an example, right? To say, well, this isn't the case. And then take that, what we might say is countering the first one, and see if it holds true for the second. And then see, can you make a set A and a set B where both of them fail? Yeah, I think you can. So that's what we got to get to with the student. Hey, that's a great idea. Good thought. Let's look at that. What about these two sets? What about these two sets? And the goal of this is not to convince a student that they're wrong, but to show them a different way to examine what they think to be true. Okay. There we go. Let's see here. A student says every time he adds an element to the finite set, he doubles the number of subsets. I've now given a couple explanations of why that would work. Is the student correct? Yes or no? And then explain. So again, what a great thing from a student to start to see that connection. Okay. Let's see here. And what else? 22, I think was one of them, right? Was it 22? 22 and 23. Okay, so 22. If you use dots in the roster method, that it's an infinite set. If you ended with dots, maybe, right? 3, 4, 5, dot, 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 and nothing else. Okay, now I am implying that this pattern continues forever. But we've had others, even back in the homework, I think. Let me go back a page in the homework. I think there was one that looked like, yeah, like here, 1, 2, 3, dot, 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 25. Is that an infinite set, or is it a finite set? Okay, so that might give you some push as to kind of how you'd respond to a student there. And the student said the number of the empty set is equal to 1 since it has one element. Another student says the number in the empty set is 0 because empty set has no elements. Which student is correct and why? A good question. And this is where sometimes students kind of run into them using their own language. So is there one object that we're looking at, or is there one element? And it's easy to kind of get those words confused. All right, that wraps up our MC 22. I'll be back shortly with more. Hope you're having a great day. Off you go.